This chapter is all about tensiometers. If you have not been using a tensiometer routinely when building wheels, I'm going to convince you that you should. There are 4 different techniques that people use to try to assess spoke tension. One is by plucking spokes, another is by squeezing them, another is just relying on experience, and the fourth is using a tensiometer. Now, all of these are important in one way or another, but when it comes to accurately assessing spoke tension, there's nothing to replace a tensiometer. Now, plucking spokes will tell me a little bit about the consistency of the tension on them. So if I pluck these spokes, you hear that the tone is about the same in them. So I can assume that I have pretty good consistency of those 3 spokes. But the frequency emitted by a plucked spoke depends on not only its tension, but also its length and thickness. So 2 spokes could easily emit the same tone, the same frequency, but have vastly different tensions if their length and thickness is different. And likewise, I would argue that going around and squeezing spokes gives you kind of a qualitative sense of how tight they are. You can certainly tell if they're somewhat tight versus very loose, but once again, you can't determine the amount of tension in the spokes. One of the books that I have in my collection of wheel building books is written by Gert Schroner, who was a long-time well-known wheel builder in the European circuit. Here's a picture of him here, and this is a quote taken directly out of his book. "I worked for years without a tensiometer, being under the false impression that instinct and experience were enough. Then I bought a tensiometer and started making measurements. Shamefacedly, I had to admit super instinct was not so super at all. Since then, I work with the tensiometer, and it is always at hand next to the truing equipment." Probably the most widely used tensiometer is the Park Tool TM1, shown here actually being used to measure the tension on a spoke. A tensiometer measures deflection, and that provides a number which has to be translated into kilograms of force with a conversion table. So really, a tensiometer is only as good as the conversion table that accompanies it. This side of the conversion table allows me to take readings from the tensiometer and convert those into kilograms of force for round stainless steel spokes, round aluminum, bladed aluminum, round titanium, bladed titanium, Mavic aluminum bladed, and Spinergy spokes. An example of using this table could be the following. Let's say I'm measuring the tension on a round 2.0 stainless steel spoke. That would be that column there that I would use in the conversion table. And let's say I have a reading of 25 on my meter. So I look at that row there, and I go across that row, and I see that I have a spoke tension of 120 kilograms of force. That's that number right there. So it's a very easy table to use. This is the other side of the conversion table, and this is all bladed spokes. And these are bladed stainless steel from a range of dimensions of 0.8 millimeters by 2 millimeters all the way up to 1.7 by 2.3 millimeters. The Park meter is very moderately priced. It's durable. It's not overly delicate. If you drop it, it's not likely to break. It comes with an extensive conversion chart, as I just said, and it's also backed by Park's guarantee. The Park tensiometer comes with this handy little tool which can be used quickly to measure the diameter of spokes. This is another good tensiometer. This is one made by DT Swiss, and it's an excellent tool. The conversion table, however, is only good for DT Swiss spokes. This is probably my best and most expensive tensiometer made by Supreme. Note the really beautiful high-end Mitutoyo digital gauge. This tensiometer is calibrated for Supreme spokes, And I use so many Supreme spokes that it's important to me to have a tool that I know is calibrated specifically for those spokes. This is the conversion table that comes with the Supreme tool. The tool also comes with a calibration bar, so if I want to check the calibration, make sure it's accurate, I can insert the bar into the tensiometer and make sure that I get the correct reading. Then I know it's still calibrated correctly. If it's out of calibration, which hasn't happened to me yet, I'll just have to send it back to Supreme and let them recalibrate the tool. Here are a couple of other really nice tensiometers that are available on the market.